with growing needs of systems for managing various type of events. Maybe it is for a good purpose, or maybe for an emergency purpose, or any scenario can happen and can be taken, can be considered. So one has to prepare for, I would say, like if one is preparing for very good scenario, he's considering that everything will happen in as per the expected way. But if something not happen in that way, then how we respond to that system? Whether we are ready to respond, or we need support from other streams. So this talk is all about like how various streams will come together and develop a system so that uh, the events like disasters which affect lives and economy of any countries, and very presently, we are suffering from COVID-19, one of the pandemics which has been become a global case. So we'll see how we are planning, and we are interacting with such events, and how whether our preparedness level, our readiness level are sufficient or not. So first thing, whenever we saw the brochure of this event, the first thing which came into our mind was like, system engineering. Although we are very much familiar about industrial engineering terms, but we are not interacting much with. We are interacting with system, but not with system engineering. Right? So it is just, although Professor Mahanti has discussed a lot about systems and system engineering, but still just to rephrase from my perspective, and from a different, you can say, second thought on system and system engineering. I'm just including few slides, and I will club like how this system engineering is very much relevant to the disasters and pandemic cases. As per the very broad definition, it is an integrated set of elements that accomplish a defined objective. It means that it is not a single entity. Like you can't say like within an institute only say director office is there, or you can say only some departments are there, but no other systems are there. So it means like it is incomplete system. You can't fulfill your objective. If a student takes admission into any institute, what is his objectives, his aims? To be a good engineer, to be a in which stream he is taking, he would or he will learn, he or she respective will learn all the concept of engineering to his respective branch, and become and come out from the system with a degree. It means that it's not only the teacher who plays a role to a teaching system, it's admin, it's lab staff, it's other scholars, and hostel administration. So there are a lot of small, so you can say subsystems are there. But when you talk about a institution, it's a we say like okay, welcome to our system. It means that it's a integrated. We are talking about the holistic view. It's not about a single entity or a small thing. Okay, examples could be like of systems as large as international air traffic control. Any traffic control here, even our road traffic control system, and as small as integrated circuit chip. Chip may be a part of a system, but it has to play some role. It has to be integrated with other chips, other circuits, other systems. Maybe if it is for mobile, then other things will be connected and then it will function. We'll say that, okay, this is system. Like for computer or PC, sometimes we call it system. It means that it is made of various things, small components. They form a big system. When you talk about systems, it means that we are observing a large picture rather than a narrow or micro aspect of it. So, a very good definition which I prefer in my class as well. Like system engineering is a formal process. Just read the definition carefully. Formal process. It means that it is a process. First, development of a complex system. It means that system is complex. Overall system is a complex, but it requires a formal processes, small processes by a driven by a set of established requirements. Every system has certain requirements, like we check, okay, whether this is there or not. Okay, like hostels is there or not, mess facilities there or not, good teachers are not. How is dean director faculty have certain qualification, right? So these are the some requirements for student perspective. And for for faculty perspective, like we see that, okay, this particular institute is giving what sort of facilities, how much, where it is located. So there are certain like requirements for a particular, say for a case of you would like to purchase a mobile, then you will see what are the requirements: camera with good pixels, okay, screen size, and other aspect. You see, the price derived from the intended mission of the system. It means that it should fulfill its objective throughout its life cycle. And until and unless you have mobile, you want that that particular mobile should fulfill the purpose, whether it is for 1 year with you, 2 year, 3 year, as well as it is applicable to all systems. It means that we have to take care of each and every aspect while designing a system. That's why it is a called as integrated approach to include all aspects. We'll see with cases we will understand how it is processed. Some other definitions which includes, I'll just read the no, just a second. Keywords. It is a definition by system engineering from the International Council of System Engineering. It says it is an interdisciplinary approach. It means that only one person, like, okay, for designing a mobile or computer or a vehicle, only one engineer is not sufficient. It requires efforts from all streams. Okay, so that's why we'll say, okay, this is design section, this is operations. Okay, in any industries, any factory, quality as also discussed by Achilles sir. So a lot of things are there. So that's why a system requires approach from all disciplines. Another definition reads integrates all discipline. Okay, and describe as a structured development process. Third definition focuses on developing solutions. It means that whenever you thought to design something, whenever you thought to produce something, you have to write each and every things, every design aspect, every aspect of it, and see whether it is a part of system or subsystem or another small. So everything you have to consider. So that as well said by Manti sir, like you can do the re-engineering. If any issue is there in the system, you can do, okay. You have manuals, you have everything written with you. Yeah, okay. For I'll discuss this. See, what are the first we have to identify the requirement. This is a V diagram, V model, which is a graphical representation of a system. Development life cycle, how a product is developed. It starts from design, how a system will appear. Then what are the subsystem requirements? We have to design small things. Then we have to design small components which are associated with subsystems. And we have to realize, okay, now we have to check whether things are as per the requirement or not. There are two things. One is verification, and one is verification. I'll tell when I recall the things. Then again you have to this was the left block of the diagram V model, and in the right side you have to check, you have to verify, you have to like whether whatever the systems you prepared, you made, you developed, whether that is as per your design expectation or not. You have to check the dimension, you have to check the uh, feasibility, you have to check the operations, whether the particular system is in working condition or not. So likewise, you have to check each and every component, every subsystem, and eventually you will be with your product. See now how this particular this entire system engineering is relevant to disaster. I'll now switch to disaster related case. Then I'll integrate both things in upcoming slides. I will take the definition as given by Indian Disaster Management Act 2005. It says that any event which arising from a natural source or a man-made cause by accident or negligence and which affect which results into terms of loss of life, human suffering, damage, destruction of property, or damage to or degradation of environment, and is of such a nature of magnitude, it means that it is beyond the coping capacity of the community of the affected area. See, every year, say for Assam, I'll take a small case. This year, all districts were affected by flood. Bihar, in the same scenario. Kerala, few districts were affected, and some part of Karnataka, Tamil Nadu, and this time Maharashtra, Madhya Pradesh, Uttar Pradesh. So likewise, Uttarakhand. So every year you can see some sort of disasters are happening. We'll see the like statistics across the globe. Not only India, we know we can count. It is countable. It is in this state, in this part of India, in this form. I was just counting the name of natural, but there are various man-made disasters as well. See the statistics. This is for globe, not for India only. You can say in 2019 only, you can say the number of disasters are mentioned. Flood, you can see the frequency of flood across the globe is maximum. 194 times flood has affected the world. It means that various part of the world has been affected 194 times by a flood. It's not only that when there is a community is being affected by that, then only it comes or term as a disaster. So next is storm. Storm, you can say cyclones are there, maybe depression, deep depression, likewise. Wildfire, also a number of places reported that there were in the particular forest, including Amazon. Landslides, extreme temperature, heat waves, earthquakes. It is data for across globe, and the bottom data shows that it is the average for 2009 to 2018. So you can say the average flood is higher. It means that the frequency of flood is increasing, right? As well as earthquake. Only the storm was a bit low, but other say wildfire. So other disaster, it means that the frequency and occurrence of disasters are increasing. So it means that we have to adopt some holistic approach so that we can control, we can minimize the risk associated with these disasters. I'll explain that how the people are being affected and not able to get the proper response. And this is the statistics for number of deaths. You can see because of flood and because of cyclone in other places, it is also known as hurricane or tornado. So, and wildfire, earthquake. So number of people, you can compare it from past years. It is the data you can say for 9 right, say 12, 13 years data is there, or say 20 years of data. So with respect to 20 years of data, how this the past year was, we can say the frequency is and the number of deaths are also increasing. In case of number of people being affected, you can see again this cyclone and flood on the top. And next is the drought. Various countries are also affected by drought, including various parts of India and Asia. Overall, I would say that Asia is one of the most disaster-prone continent, followed by USA and Australia. Next is disaster management cycle. Then the question arises like how to manage these disasters. It means that whether what sort of activities one has to follow, how other countries and how government of India is following, which approach they are adopting to minimize the risk associated with disasters. So this is the cycle. It means that why I am showing it informed cycle, because it is like a system approach. So if one thing is start, it means that everything has a relevance with each other. If you are preparing, it means that you are preparing for something. Okay. As well as you saw in V diagram, we were in left side, we were in design phase, we were in requirement phase, and in case of right leg, we were at the verification phase. So first is preparedness, second is response, third is recovery, fourth is reconstruction, and fifth is mitigation. In general, it starts from mitigation. How, why, and how I will let you know. We see the definition. It says that it includes the sustained action to diminish or eliminate the possible threat to people and property from potential hazards and their consequences. It means that you have to prevent the disaster. You have to prevent it from happening. It means that if there is a dam on the river, then the lower side of that particular area will not be affected. It is an mitigation approach. Construction of hospitals, it is mitigation. It is not preparedness, because preparedness means instantly how you are preparing for that particular event. You are preparing for exams. Throughout the year, you can't say that you are preparing for exam, right? For a particular moment, maybe for last 10 days, we prepare for exam. Right? For next is, so preparedness says it includes various plans to develop related to developing various plans, like how things will move, how say for if you are preparing for COVID-19, then what are the various plans, how we should move, what should be our approach of government level, and then state level, then district level, then village level. These are the plans, structures. Everything should go in structure way. First, it is a you can say like written statements. First, this event, this thing will be carried out. Then decide. Like first for corona treatment, first you have to what you do. First, you have to go for test whether we are affected by corona or not. Then after that, you will be shifted to particular locations or a hospitals or isolation wards. So likewise, so these are the structures and processes. Processes how these things will happen and execute. One has to execute them before a disaster. It's not like that particular event has happened, then you are going there. That is the response, not the preparedness. So response is the task of using the resources and disaster management procedures to preserve life, property, environment, and socio-economic and political structure of communities. Right? So it means that it's not only saving of lives of people, but you have to take care each and every aspect of our human system. Then recovery, it is the process of repairing damages and restoring human and infrastructural services. Next is reconstruction. So, recovery, actually, you try to recover. In case of COVID-19, we say the okay number of like percentage of recovery is very high in India. We are saying that okay, this time it is 89%, right? And the fatality rate say 1.58 or 1.6 likewise. So we also express in terms of recovery. In terms of reconstruction, like any bridge or any building is collapsed due to disaster, then it should be reconstructed rather than recovered. And see, during this cycle, one has to reconstruct in such a way that it will act as a mitigation. We have to construct building bridge in such a way that I'm getting noise from participant side. Is
I
mute your
request,
mic.
hello, I request participant, please mute yourself. Please mute yourself. There is some disturbance. Rashmi Dwivedi, Dr. Rashmi Dwivedi, Dr. K. Ramesh, Dr. Rashmi Dwivedi, Dr. K. Ramesh, Dr. Rashmi Dwivedi, Pradeep Kumar ji, Pradeep Kumar ji, Pradeep Kumar ji, mute yourself. Please
Yes,
mute
sir.
yourself. Please mute yourself. Rakesh, are you there? Rakesh, 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 please mute yourself. One minute, Dr. Yadav, 1 minute. I just settle these things first.
Okay, sir. I think now it's fine, sir.
Yes, you can go ahead, Dr. Yadav. Now
Okay.
yeah.
So earlier we were discussing about the disaster management cycle, but when we look the cycle in terms of logistics point of view, then probably we are very much interested to these three cycles, that is preparedness, uh, response, and recovery. Because for disaster, it's not like every disaster is can predict in advance. If you cannot predict, it means that you have to prepare overnight and you have to respond immediately, as well as you have to take care that the affected community should recover from particular disaster. So, since these are the major and very specific, carries very specific needs, so that's why these are very relevant for logistics point of view. So accordingly, this was the need to focus on logistics point of view. The Fried Institute in France, they thought they looked the disaster management cycle, and in terms of only logistics point of view, they defined and they termed it as humanitarian logistics. Humanitarian, it means that one has to perform his duty to save the life of people. He has to be humble and kind and provide the rights of living to not only to himself but to others as well. So, as per the definition, it is the process of planning. It means that one will plan, implement. The planning will be implemented and controlled for what and how, in efficient way, cost effective way, and one has to storage the goods and materials so that whenever there is a need, that materials can be demanded, and as well as related information. Why information is needed? Because the sufferer, the people who is located at the last mile location, he has some hope that government or any system will help me, will come to me to save my life. So we have to consider such aspect, and from that point of view, we need logistics support. We need system to reach up to the last mile location. So for that, we have to focus on preparedness. Then only we can respond. We can rescue the people, those who are at risk, at disaster and risk zone, and we have to provide sufficient help for their recovery. Right. So with the focus of logistics in supply chain, humanitarian supply chain concerned with preparedness, including mitigation, response, and recovery. See why it is mitigation, because one, you have to keep the things ready. You have to prepare, means like say you have to go to, you have to reach, you have to send say 100 people to a particular location. Okay, there is a scenario. Into that, what mitigation will do? Here mitigation will help in availability of such huge manpower, trained manpower. A system will be there, no, so that such people can reach there. Preparedness, okay, I can say by that 100 we require 100 people within overnight, but such people should be available somewhere. So that is called mitigation. And then for recovery, it includes reconstruction. If their home, if their houses, if the roads, public infrastructure is broken, that should be reconstructed for recovery. Otherwise people, if bridge is broken or road is broken, power cables are broken, then recovery is not possible. For such cases, some reconstructions are also required, and that's why it is included within the recovery part. Now, if you see the major difference, like how this humanitarian supply chain is different from the traditional supply chain. Like here, we need information. In every supply chain, we need information should flow between supplier, stakeholder, beneficiary. There is a supply point, there is a uh, demand point. So one has to go from supply to demand end. Who are the supplies for such cases? Donors who will donate something, NGOs who will uh, uh, assist the government bodies, army, humanitarian agencies, all will be there as a supply of relief or manpower required. So what are the things required? Information, material, finance, people, trained people, knowledge, how to rescue. It's not like one will go. If one people is in the risk, then another people will jump into the river, say, for a case of river. So it is not like that. So for that, we need some knowledge, we need some skills. There is a fire, you can't run and you can't bring out the people. You need some sort of skills. Likewise, so that's why here knowledge and skills in people plays major role. For whom? For the beneficiaries. So humanitarian supply chains serve as a bridge between disaster preparedness and response, between procurement and distribution, and it is also very crucial to the effectiveness and speed of response for major humanitarian programs such as health, food, shelter, water, and sanitation. Right? Though it can be one of the most expensive part of relief effort, one has to perform his duty to save life of peoples. So now it's time to club the system engineering approach with our disaster management approach. We'll see what are the systems which required in humanitarian and disaster for managing disasters. Okay, we have Indian Meteorological Department, which provides us uh, all early warning. If there is any depression, deep depression in the Arabian Sea, in the west, this uh, now various seas, what I say, Bay of Bengal, right? So immediately that comes into the notice of people as well as our media partners. Then Home Ministry is also associated. It provides the necessary guidelines. Health Ministry, if any pandemic, any virus cases are reported, police will be there to control the people and the supplies, and to control the other relevant things. NDMA, National Disaster Management Authority, National Disaster Force are also there. The response force is also there to provide relief to the people. State disaster, district disaster management authorities. Every state has a state disaster management authorities. Their duty is to take care of the disasters which are coming or happening in their states. NGOs has also major role because they are the one who can get sufficient donation from donors, and they are doing various NGOs are doing really good to perform their duties in saving lives and providing various relief materials, relief kits, PPE kits, and other things to the needy people. Early warning systems. So warning system, it means that one, if you have warning, one you have to disseminate to the people. Systems means you have message, you can WhatsApp, you can watch on television, you can press it on news papers. So these are the various systems, and as well as government also announce through different modes, maybe from their loudspeaker or their vehicle. They have their own set of arrangement for each locality. So they do according to the requirements. Municipal also has major role if it is for urban areas, hospitals, healthcare units, suppliers. For cases, you can see like one has to ready to supply round the clock. The demand of say for blood can be demanded. There is a demand of blood at any time. So one has to ready for such system. One has to be ready with a vehicle. One has to ready with required refrigeration system. Likewise, warehousing for storage of essential and goods, transportation for supplying of essential items across the country until last mile locations. Railway. Sometimes government runs special trains. This time you have seen various special trains, summit trains were also applied. In goods train, also applying to supply the relief from one state to another state. Air services are also used for airdrop. Air ambulance are also used for emergency cases. If any patient is in a very emergency need, air ambulance is used. Rescue. Sometimes it is also done for rescue. Last year, if you could remember, there is one flood. There was one flood reported in Nanded or somewhere. I forgot the name of the district, where the entire train was almost under the water. So at that time, helicopter and other things were used to rescue the people. And at most, not but the least, people. People means we. Population under risk and donors, if they are not under risk and located at safe places. Donors means they has to donate something so that the people, those who are under risk, can save their lives. So accordingly, we will see like how we will categorize now how everything can be put into different needs. What are the things which are required for preparedness? How the government, how with the people, how the community is preparing themselves for a pandemic, for any disaster. We'll take a case of say flood disasters. So now I'll ask participants to participate and suggest me what should be the activities that should be carried out to prepare for floods, and then for response as well as for recovery. Audience, please. Participants. faculty members, scholars. Some suggestions would be appreciated. How to prepare? What should be the activities that should be carried out to prepare for a flood, maybe in your state? If everything, if every machinery, every system is ready, then only we will be able to respond to the case, respond to the disaster, respond to the flood, and then only we can talk about recovery. So first, the activities, the system which are required to prepare for floods.
Proper drainage system.
Proper drainage system. Next, any other suggestions for flood? How to prepare?
Specialized people like swimmers who can take care of the people if they are entrapped in this kind of situation. Yeah.
So,
Then we need plant and mobile boats and other things also we require. Availability, sufficient availability. Life saving jacket.
life-saving jackets, kits.
Yeah, please.
Likewise, we can have a large number of
Evacuation of people.
evacuation. Evacuation can be a part of response. So preparedness, how you will evacuate. So you can say planning. Okay, how you will plan to evacuate. Whether you whether people will come by walk or they require vehicles, right?
Places have to be made.
What?
Safe places.
Shelters.
Shelters.
And in response, we can evacuate. We can distribute food items. Okay.
Sir, in the preparation stage, we can form a team which can look for the weather forecast and which can alert before the floods will arrive.
So we have also like trained skilled manpowers are there. Their duty is to sensitize the people about any upcoming unforeseen event. Early warning system will be there, but preparing means we have to tell to the people, we have to warn the people, right? Next, anything else we could include here?
Availability of medical staff also, like if
Yes,
you
sir.
look after.
We can take, we can also see like we need hospitals are there, relief items, air service are must be ready, air transport and other suppliers should be ready. So we have to check everything, like whether everyone is prepared for whenever there is a call to supply, one has to reach there. There is something called planning. They
In
have to
preparedness, there should be some drills also.
mock drills.
Drills.
So I'll share one more relevant paper just uh, to see what are the other activities which are. Is it visible? This PDF file is visible, sir?
Yes, it is visible. Yes, yes.
So in terms of infrastructure, we can see see it is also a part of, as I told, in preparedness we can include mitigation, although it is a construction of warehouses are a part of you can say mitigation, but that should be in the place and we can see the conditions, construction and maintenance of public buildings, cyclone shelters, arrangement of power, water, toilet facilities, okay, all weather roads, canals, drainage, and for early warning, existing meteorological systems, we have to check, ensuring timely collection of early warning. Okay, arrangement of multiple channels to disseminate fail-proof multilingual warning for community at risk. Okay, documentation of information, establishment of high-frequency wireless network so that in any case there should be no coordination gap. In terms of resource management, one has to prepare sufficient. Means government or NGO should have sufficient financial resources. Arrangement of donation, web-based inventory, that which inventory is located at which place. Then hospital capacity planning, that although we have a number of hospitals, but whether what is their capacity, whether they have how many beds they have, how many beds they can expand in case of need. Like for COVID-19, they are now expanding their facilities and occupying the, so that a number of COVID patients can be accommodated. So likewise, procurement of necessary essential equipment, process for supplier selection, preparing emergency response plan in coordination with other organizations as well, selection of strategic routes in safe locations, arrangement of vehicle for evacuation and relief distribution. Okay. What are the human resources required? Strengthening of disaster management organizations, whichever organization is there in the state or district level, training of personnel and stakeholders to respond to disasters, arrangement of security and volunteers, strategic collaboration with national and international relief organizations, including we have to we have to increase the capacity of our community. For that, we can educate the communities, we can assess the vulnerability, and we can suggest critical suggestions, and we can include disaster planning by local government and NGOs with local people. Regular mock drills are suggested by sir, and encouraging household preparedness program for vulnerable communities. It means that it not only at the government side, it should also from the community side. So now we will move. We will see how system engineering is coming into the picture. Since this talk, this FDP is all about system engineering, we will try to integrate. Just read it. Disasters may have a huge impact on lives and economy. Lives, human, animals, birds, anything. Economy, manufacturing, communication, workforce, availability of goods and services. So disaster can affect anything. So what is required now? We require systems to save lives. First, second, systems to avoid economic disruption activities. So economic activities should go, in a regular pace. So in this case, system engineering connects various subsystems which we discussed in previous slides to manage disasters, both man-made and natural, and reduces the disaster-related risk. And what are the system engineering approaches? Various people are adopting various sort of approaches. I'll just go through. Information management system for emergency management. Okay. Location allocation problem for emergency blood or medicine or ambulance supply. Water level for flood. Coal mine disaster using casual analysis, as discussed by Achilles sir on yesterday. Cause and effect diagram. Okay, we can map activities by using what the cause for particular event, particular disaster. Either it is a fault of man, it is a fault of machine, it is a fault of system, it is a fault of like maybe human factor, anything. We have a detailed discussion, detailed point out of each and everything. For that, what was the cause, and accordingly we prepare a cause and effect diagram. Then developing a system management framework for the Kerala, Odisha, Uttarakhand, different states you can take for flood disaster recovery. Study on the causes of fire and explosion disaster in chemical industries. So everything, it is basically a system approach. All these problems require system-based approach. You have to identify a system indicator for safety performance measurement using a system engineering approach. So these are some cases which are available. I'll send a few of the research papers to you as well, so that you can have a great idea. You can have a very good idea at how system engineering is very much relevant to disaster cases. Right, I'll discuss one or two cases in coming slides. See, it says that hospital capacity planning for disaster management. Okay, everyone knows that hospitals are an integral part of a society's critical functions, which designed to respond to man-made and natural disasters. Okay, any event is happening, maybe it's a accident or flood or earthquake, anything, we need hospitals for that. But effective hospital capacity planning requires various approaches so that it can significantly enhance the capability and effectiveness of treatment for emergency patients which are affected by any kind of disasters. We'll see another case. It is very much relevant to present scenario. COVID-19, every day we were talking about COVID-19. So I'll just I'll just share the statistics of COVID-19. I'll back to the previous slides. World, across the country, across the globe, 215 countries are affected by COVID-19. These are the present case, number of deaths, recoveries, active cases. In India, total cases are 63 lakhs and going on. Active cases 9 lakhs, recovered 52 lakhs, tested 7.6 crores, and deaths reported till today are 98,739. See, for such a pandemic, it is now included into the Disaster Management Act, like pandemic can also be termed as a disasters. So we'll see. It is relevant to present scenario, improving patient safety. Patient which is coming to the hospitals, okay, for this corona test, In system productivity, how much a system is productive for patient safety as well as reducing the time for corona test. Okay. So COVID-19 shows that how hard system engineering involves manpower, doctors, nurses, healthcare supporting staff, volunteers, and others. Okay, manpowers, machines, thermal sensors, testing kits, sample collectors, safety equipments, laboratory instruments to detect novel coronavirus, etc. There are various things will be there. So it says that COVID-19 shows that how hard system engineering. Okay, system engineering was used to bridge the gap between the current and required performance of the processes for corona test. Right. So corona test, I'll discuss about corona test. This is the present scenario for corona test COVID-19. There are two sort of tests is being performed: RT-PCR test, which takes 3 to 8 hours, and second is a rapid antigen test, which takes about 30 minutes. So there are two different. It is used basically uh, uh, performed by using the swab, both tests, but it requires chemicals are used to remove proteins and fats from the generic materials, and the sample is put through machines analysis. And in case of rapid antigen, it are designed to detect a specific protein in the virus that elicit the body's immune response. It means that whether it is your immune system is able to respond to that particular virus or not. So there are two tests. So why I am discussing this? Because initially the number of tests were very less, the time taking was very high, but now system, because people are we can't see if any patient is coming to a system, to a hospital system, and for the COVID test, and if he's not getting the result, maybe either is a positive or negative, then if unfortunately if he's positive and interacting with other people, other may also be affected. So if the test time is less, then certainly required measures can be taken for such cases. So what are the various systems required for treating the COVID-19 patients? Maybe testing facilities, testing centers, hospitals, volunteers, state governments, police, quarantine centers, ambulance. No, there was a typo error. It's corona treatment centers, isolation wards, round clock information assistant. If a patient is calling to a toll-free number that I am not feeling well, I need immediate assistance, then certainly there will be arrangement of ambulance by respective states or health care department. Arogya Setu app, Seva Sindhu apps, various apps are there. Seva Sindhu is basically, it is in Karnataka. Arogya Setu for every Indian has to mark himself whether he is safe or he is feeling well, he is not feeling well, like this. Data management system. So see, you can see large number of data, large number of people are being affected, recoveries, free, you can say, as I shown the cases. So there are lakhs of cases are there. So for every patient, we have to keep the data. And then sample collection, it is also a difficult task. Form collection at airports, bus stands. So you can see a large number of data is being collected. So for some useful suggestions, someone has to analyze the data and give proper suggestions. There is programs for the best outcome in tracing, isolation, communication, and treatment for COVID cases. And most important, training for healthcare staff. See, if all these systems are required to make a people corona free, all when everything will be put into a right way, then only a people or any state, any community which is about to affected by COVID-19 will be recovered. Otherwise, there will be the consequences can be anything. Right. So why I am discussing, because it's not a one thing. As I told, that system engineering requires a process from all the streams, all the people, all the bodies, all the subsystems. You can see large number of subsystems are there, but everything is required, right? So that's how this system work. I'll take one case for Karnataka, how Karnataka is preparing for COVID-19. They are using some five approach, five sutra, you can say. First is technology and innovation for contact tracing. If I say one is COVID patient, so I'll ask to that patient that with whom who were others in your contact. So likewise, we'll keep tracking, and it will keep going. Then only we can trace each and every people those who came into the contact with a COVID patient. Then various things apps are there, helpline centers are there for cluster management. There institutional quarantine facilities apps were there to register like you are at quarantine center. What are the issues? So for that they developed a Seva Sindhu app. Awareness strategies. They made a special task cell for awareness, mask day campaign, for health risk survey. They are physically and through phone based they are conducting surveys that people are safe or not. They are asking people to wash their hand regularly and wearing of masks, so and so. So like, and then testing and hospitals management, testing and treatment cost were kept low for from starting in the Karnataka state, so that people do not feel hesitate to that before testing for testing. And two-layered hospitalization process. If a patient is very serious, then he'll be taken into the different hospitals, and if he is just not feeling well, has some cough and cold and some other issues, then he can be treated at home itself. So these are just the learning, like how the system is working. Everything has to put into the picture. It's not like it will escape one thing from the system. Then it's like in supply chain, if one link is broken, then it's not a chain, right? So for that, all these elements are the part of that chain, the links. So every link has to be connected for better society and COVID-free society. So now, we have to think: are we really gearing up for such pandemics? Our infrastructure is ready or not? Our healthcare facilities, our transportation, logistics, institutions, are they ready for another such pandemics? Technology, whether we have a rapid test capabilities, whether we have facilities to detect virus at early stage, and prevention. As I told in mitigation, it is all about prevention. It's not like management. Disaster prevention, not disaster management. If you are able to prevent particular thing to happen, then you are at safe zone. And if you are thinking like I will manage what event will happen, then no, you are at danger side. Manpower, we require skilled manpower for each and everything. A large number of volunteers are visiting to various localities so that people can be sensitized about how about this virus and how it spreads. It should not spread into the community. So likewise, and for taste, it's not like that. Our healthcare staff, our doctors are also suffering because of COVID. So likewise, one has to be like skilled. Since this is the first of such cases, and we were not really prepared, but we are very sure that in future we are much prepared for such events. Responsive system should be very responsive. If anything is happening, we must be able to put our all resources to respond, quick response, agile. It's not like we are very rigid to responding, that we will respond to a specific community, specific people, specific set of people. We have to respond to each and every people. We have to be very agile in responding. Completeness. It's not like, okay, you tested that particular fellow is COVID positive, but what next? You have to provide sufficient treatment, required treatment, so that he'll become a COVID, his reports come negative. Then only your system will be called as complete system. Otherwise, it is just a subsystem. Tested, okay, positive. then what next? We have no idea. So completeness means all efforts should be available so that people take the advantage of available system, whether it is institutions, healthcare, transportation, everything. Round the clock ambulance, round the clock hospitals. That's why for medical it is 24-hour facilities are there, because it is also a part of system. If anything required, then where will you go? Logistics. Logistics include all the activities related with from a transportation point of view, or maybe providing the facilities point of view, or providing the sufficient services to you. And everything it includes comes under the logistics. Then community awareness and capacity building. Right? Whether we have our aim is not only just to be aware themselves, but to make aware others as well. Capacity building, we have to give required training, mock drills, sufficient slogans, messages, movies, videos, in whatever way we can provide the information, we can provide the knowledge to the people. We should keep. See, this FDP is also a part of capacity building approach. Our aim is to sensitize a huge number of participants, around 145 participants, as per best of my knowledge we have. So if I'm not saying they'll take every aspect of any presentation, but even if they are able to take a single or a small aspect, I would say that their capacity, thinking capacity, or maybe that acting capabilities is enhanced. What are the advanced system and technology required? Capacity building, as we already discussed, it is a system which requires to train the people to improve the capacity. Not capacity building means how people are able to respond to a particular disaster. If I know everything, that this will happen. If there is a earthquake, one has to either keep or run outside from a building, or stay away from a building, or stay away from roof. So it means that we know these things. So these are the knowledge which make us capable to prepare, to respond to any disaster. Early warning system should be there. Disaster prevention. I'll always I always focus on disaster prevention, because if we were able to prevent a virus at very early stage, the scenario would have been quite different. Economic, you can see huge, economic loss is there, because different systems are not able to work properly, right? And then scenario building. I would say, like say in Delhi we have 1,000 cases on a particular day. Scenario says that if there are 5,000 cases, then what will happen? So one should adopt such approaches. That is called scenario building. There is a huge flood, and say near to any river or any lake, I would say Bhopal Lake, say. So if there is a huge rainfall, then I have to develop a scenario. The scenario is that the VIP road is somewhere broken. Then what will happen? This is called scenario building. Then which road will be used for transportation or logistics purpose? How that thing we repaired? How we will evacuate the people if any people are nearby? Also, applications of 3D printing. 3D printing is a recent technology which is capable of developing or producing the required design of part within hours. So you can develop a one kind of structure, you can develop a brick kind of structure, you can develop a table kind of structure, you can develop, so different structure can be printed. Printed means it's a 3D part, right? Although maybe made of some not the metals, and different, say, other materials are being used. So, but it is a system. It is a a technology which can be very much relevant to disaster cases. Data analytics, a large number of data, even for COVID, you can say large number of people are showing graphs, curves. This will happen if we'll follow by this regression. The peak will be in September, the peak will be in October. Likewise, so if as per the someone has say like by analyzing some data, that peak will be in September. So I would say around 15 or 16 September, the cases was on a single day, the reported cases was 97,000 something. So I think that was the peak. So likewise, people can predict, utilize the next is utilize the opportunities provided by social media and mobile technology for disaster risk reduction. Next is knowledge management. We have some local knowledge, we have some different knowledge from other countries. Developed countries will say, will take knowledge from how the New Zealand is responding to COVID, how Japan is responding, how America is responding, how UK, how other countries are responding. Right? We'll take the best cases, we'll take the benchmark cases to design our system. We'll develop our like for our syllabus, whatever we design, we take the examples from various stakeholders, various universities, top universities, foreign universities. Next is hazards mapping. Like we can show on a map this particular area, this particular district, this particular part of the country is under risk and vulnerability. Which kind of which thing are by what system is making them vulnerable, whether it is disaster or lack of support from government is making them vulnerable, right? So we have to assess all such things. Next is application of blockchain technology. It is a data driven technology. It is used for so that there will be no communication gap, no data loss, no information gap, right? So that everything should be in system. No one can steal the data. The data are secured. Next is industry 4.0. One has to read IoT, big data, data analytics, cloud system, smart manufacturing. Likewise, things can be also added for managing the disasters and to make them to bring various things into the system. So I would summarize this presentation. We discussed the detailed description of importance of system engineering in disaster scenario, that how different systems are coming together to make a system, to make a community a disaster free community. And we also saw the Karnataka strategy, how Karnataka is gearing up for COVID-19. We also saw the various suggestions to prepare for disaster, including COVID-19. We also discussed advanced system technology for managing disasters. We also discussed various research opportunities for disaster management and humanitarian supply chain cases. Here I would say that, after this talk, maybe, or maybe after say 10 or 15 days, we will not be in a position to recall what we heard, what we attended, what was the talk. But we have to remember certain things, like what were the research opportunities. See, we always can't say that this country has this much resources, so they are growing in research. We also have resources. With limited resources, various research has been done in the country. And today we are planning for, we are gearing for sun or moon mission, or different satellite missiles. So all these, so we can't always blame for the systems, but we have to manage with. So that's why, if there is a how we manage in a disaster scenario, how people I am fortunate to meet with the people, those who are affected by various sort of disasters in flood and cyclone and other diseases. And when they share their experience, then I could thought that it is not only the people, me and you, it is the system, it is the whole system which is responsible for making a disaster free community or a disaster free country. Next are the always remember system engineering is all about completeness. It's not about one entity, but it's a complete system, a detailed life cycle approach. One has to think about every aspect of a system, every aspect of that particular part. For that, you can say, circular economy is also there for manufacturing, for this machinery related components, how what will happen after 10 years of that particular vehicles, machines. So likewise, so one has to think in that way. I'll also share few papers with you so that you can get the more into this research. It's my advice, it's my suggestions to do some sort of research so that this country will grow, and we will also put ourselves into a on a front foot, that okay, we are also gearing up, we are also capable to setting the various milestones. So with all this, I would say thank you to everyone for attending this talk, this FDP and this session.
Thank you, sir. Thank you, Dr. Yadav. बहुत बढ़िया, excellent talk, excellent lecture by you, and
Thank
you
you, sir.
have
Thank you.
clubbed the COVID present scenario with
Yes,
the
sir.
humanitarian logistics fantastically. So now I can say that you are a perfect professor.
It's not a blessing, sir.
So now you are in the right direction and become a perfect professor. Yes.
It's all your teachings and suggestions which are helping me.
No. Now you are in the very forefront already. Your lecture and your slides shows that you can. The future is of yours.
Thank you, sir. And also suggest participants that please interact with all resource persons so that you can get more about their topics, their area, because we are always working on recent topics, we are publishing in leading journals, so that we can maybe our small suggestions can be helpful for you. Maybe many of you are also good into the research and other domains, in teaching domains, but still a collaboration and maybe
I
suggestions
request-
will be very helpful.
I request Dr. Yadav.
Sir.
So please send some few important journals related to COVID and related to humanitarian
Sir.
to in our group. So it would be useful for our participant.
Right, sir.
And if you have some kind of reading material on humanitarian logistics, you can send it.
Okay, sure. I will send maybe by tomorrow, because the FDP is still tomorrow. So
Okay.
Okay, sir. Thank you, everyone.
Thank you, sir. Thank you very
Thank
much.
you, Dr. Devendra. बहुत बधाई.
Sir, thank you, sir. Shashi sir, thank you.
नहीं, बहुत अच्छा था. Really nice. Good.
Thank you very much, sir.
Very nice. I was there for the whole session. Very nice. Good
Great.
luck.
Okay, thank you.
Great.
Best of luck.
Thank you, sir.
अजय सर कुछ बोलना चाहते हैं? अजय सर?
अजय सर कुछ कहना चाहते हैं?
मैं केवल सर को थैंक यू बोल रहा था.
हाँ.
I will open my mic and then thank you very much, sir, for such a nice presentation.
अजय सर हमारे जो गुरु है ना, नितिन सर.
मैं जानता हूँ सर देवेंद्र यादव सर को.
तो नितिन सर के साथ पोस्ट डॉक किया है IIFT में.
I know it. सर मैंने नितिन सर के अंडर में PhD किया है.
हम सब एक ही थैली के चट्टे बट्टे हैं. बहुत बढ़िया.
तो इस तरह से मेरा इस चट्टे बट्टा होना बहुत सर मेरे लिए गर्व की बात है.
Exactly.
इसका मतलब सर आप सिस्टम में हैं, सर आप.
बहुत बढ़िया.
Nice presentation, sir. So nice, sir.
बहुत ही बढ़िया. चलिए ठीक है. Thank you everyone. So then we are meeting in the next session, which